Assalamualaikum warahmatullahi wabarakatuh. This is our group coding. This is our coding. At first, we choose the audio number 12, audio 12. At first, we load our audio first. So here we can hear the audio. That's the original audio, and then actually here is the data of the spectrogram. Then I will explain it later. Before we look up the signal, and then actually here we get the our data and our sampling time. And then we look at here. This is our length. Length is the data, and then this is the sampling time general equation. Now at here we plot the time and the frequency domain. For the frequency domain we use FFT, because FFT is decompose the signal into the discrete spectrum components and offer the frequency information as a result. And then here we use the Butterworth filter, and we use 7 order because and then this is our Butterworth filter coefficient that we use 2000 per fs, and low pass filter. And then after we load, we can get the filter sound. After that, we have to filter audio in the time domain. In the time domain, which is the filter one. Then we get the data for the frequency domain here. So for the frequency domain, we use FFT, the fast Fourier transform. Fourier transform, and then here we can here this is the spectrum, and we can run the signal. And then this is the graph that we get. So we look at here. This is the original audio for the frequency domain, and this is we can see the noise is reduced. So we can hear the filter audio. The noise is reduced, and then this is the this is the graph of the spectrum. So why we choose the Butterworth filter? Because Butterworth filter is the only smooth the characteristic in the pass band and the stop band.